Hey, Steven.
Hey, what's going on?
How you doing? How was your drive back yesterday?
Oh, it was fine. It was great.
Yeah? Good.
It was great. Hey, this is it, Dave. This is
It
the final
is.
day.
Final session. Okay. You mentioned something you didn't know about arc length.
Yes.
Okay. Arc length is the measurement of this length from A to B if you were to straighten it out. In other words,
Okay.
it's the curved measurement. And on the GMAT, the only thing you're going to need to know is that the distance from here to here is 60 over 360 times the circumference of that circle.
Okay. So the length, an arc length is the ratio of the degree to the whole circle.
Yes, yes. And what we know how to do is calculate the whole circle circumference, the measurement of the entire outside. So this represents 1/6 of a circle, or 1/6 of a circumference.
Ah.
Okay, so the circumference is 10 pi. So that particular arc length would be 5 pi over 3 from here to here.
All right.
Okay,
Um,
let's talk about that last problem we encountered on the MBA,
sure.
because there's a lot of things in that thing. First of all, it was 1 over 5 to the m times 1 over 4 to the 18th equals 1 over 2 times 10, and the 10 is raised to the 35th. Now, there's a couple of important things to notice here. First of all, we can't do anything there because we don't have the same base, we don't have the same exponent.
Okay.
If I had 1/4 times 1/4, and this was to the 16th, and this was to the 11th, it would be 1/4 to the 27th.
Yes.
Okay? If I had 1/5 times 1/4, and this was to the 17th, and this was to the 17th, then that's the same as 1/5 times 1/4 to the 17th.
Okay.
So since we don't have either of those cases here, we can't do a whole lot with the left side. And it's important to realize that. What I did notice yesterday was that 1/5 times 1/4 is 1/20th. And we're looking at a 1 over 2 times 10 to the 35th power here. So let's look at what we can do with the right side. Now, another thing that's important to realize is that if I say this, that is the same as this, because 1 to the 35th power is still 1. Okay?
All right. Hold on. So
So
you just
this is kind of an important realization here, that as long as the numerator is a 1, then I can always turn this into this.
uh-huh. Okay.
In other words, if it was 2 over 10 to the 35th, that is not equal to 2 over 10 to the 35th.
Uh,
Only,
one is
only if it's a 1 in the numerator can I do that. It's a very special case.
okay.
Okay? So, this right side, first of all, I'm going to break it down into 1 over 2 times 1 over 10 to the 35th. Okay?
Yep.
And then I'm going to break, and then I notice that the 10 is 2 times 5. Well, 5 is over here. So breaking that 10 up into 2 times 5 is probably going to be a useful thing to do. Again, with the parentheses. And then this is the same as 1/2 times 1 times 2 to the 35 times 1 over 5 to the 35. Do you see how we get that?
Yeah.
Okay. Now, what can I do with this? What is that?
Now imagine could you make it 1 over 2 to the 36, or
Yes.
could you make it?
Exactly. Okay,
How
so
about
now,
this? Could you make it 1 to the 4th 35?
well, you're close. What is 1/2 times 1/2?
It's 1/4.
Okay, so 1/4 is equal to 1/2 squared.
Yep.
Okay, so I can do two things here. I notice that I have my 1/5 to the 35th over here. Even though the 35 is in the denominator, I know that that's the same number as that. So how do I relate 1/4 to the m so that it's equal to 1/2 to the 36th?
You take it and you make it 1/4 to the 34th.
Actually, you're on the right track, but you're off by a large order of magnitude. 1/4 squared, 1/4 can be written this way. And the only reason I'm going back to the other side of the equation is because it's easier to see.
Okay.
So what is 1/2 squared to the m power equal to?
One fourth to the m squared?
Well, it would be 1/2 to the 2m, right? We're going to multiply that exponent by that exponent.
Right.
So I could replace this expression over here. Instead of 1/4 to the m, I can replace it with 1/2 to the 2m. And now I'm there. I'm at my solution. If this is equal to this, then what is m?
M is 18.
Yes, exactly. Now, I didn't have to go over here and play with this 1/4. I could have made 1/2 be 1 over 4 to the square root, to the 1/2 power. So I could have turned this whole thing into 1/4 to the 18th power. It's just harder to see the square root of 2 than it is to see that 1/4 is 1/2 squared. So I kind of preferred to do it by manipulating the 1/4.
Oh,
So notice that to turn 1/2 to the 36th into fourth, we didn't just have to reduce one exponent. We had to reduce all the way down to 1/4 to the 18th, which is amazing. That 1/4 to the 18th power is the same number as 1/2 to the 36th power, and yet it is.
Yep.
Just remember that when you take a number less than 1 to an exponent, it gets smaller. And that's the other part of this problem that makes it difficult, is that we're dealing in fractions, we're not dealing in whole numbers.
Yeah.
So they get smaller instead of bigger. But, all right.
All right, so how should we approach these last minutes here in this
Well, it's a good question. I don't know for sure how to answer it. We have a bunch of problem solvings we could do. We have a bunch of data sufficiencies we can do.
I think we should go through data sufficiency tonight, and I want us to focus really on the logic that we're going through when we run into these.
Last time we got through 135, so we can do above 135. Nine, 8, 7, 6, 5. Okay. We did this one, 135.
Let's see. Yeah, we did.
Okay. Let's look at 136. Hold on.
Okay, so we got an average problem. Use the totaling principle here. We have 6 numbers that average out to 75. 6 times 75 gives us what's supposed to be on top. $450 divided by 6 equals 75. What 6? How many of the numbers are equal to 75?
Whoops. This is 450, not 4,500. Okay. None of the 6 numbers is less than 75.
That doesn't seem possible.
Well, think about it for a moment.
Well, they could all be 75.
That's the only thing they can all be. Right?
Yeah.
Because we can't have a 74 in there. So if we can't have a 74, which would require a 76, so if there's no 74s allowed, the only way the average could be 75 is if all 6 are 75. So we can answer it with 1.
People got a great way of stating their problems, don't they? None of the 6 numbers is greater than 75. None of them are greater than 75. Does the same principle apply? Let's see. If I had a number that was 75, all 75, that's fine. If I had a number that's 74, I would require 76. So the same logic, really.
Yeah. Exactly the same.
D.
Yeah. That's one of their easier data sufficiencies. Boy, the trouble is, whenever I see an easy data sufficiency, my mind cannot help but think how tricky these people are.
Yeah.
None of the 6 numbers is greater than 75, so if there's no 76 in there, there can't be a 74. Yeah, it's got to be.
It's a giveaway.
Yeah. Now notice the stem can easily be misinterpreted here. So make sure you don't do that. They're not saying that the donuts are priced equal to the bagels.
Right.
All the donuts are priced the same as all the other donuts. All the bagels are priced the same as all the other bagels.
Correct. Now the trick with these is always figuring out, is there a unique solution of 10 and 6 that will give you only one price?
Okay, so we let X be price of donuts, Y be price of bagels. So this statement says that 10x plus 6y is equal to 1290. How many solutions does that have?
Has to be more than one.
Infinite.
Okay.
Okay? Because we have two variables and one solution. Now, some of these problems you can't automatically say that because sometimes there's only one integer solution.
Yeah, that's the way they trick you right there.
Exactly. So, see if I can figure this out. I do notice something about the 10 and the 6. That's the same ratio as 5 and 3. So I could factor out a 2 over here and say that 5x plus 3y equals 1290.
Which is a problem, because then what they're saying in effect is very little information.
Hold on. What's the total price of 5 donuts and 3 bagels?
Jeez. $6.45.
Trick question. You got to be very careful when they ask a question like this. In other words, they didn't ask what the price of a donut was. If they'd asked what the price of a donut was, we could not have figured this out. They asked a very unusual question. What's the price of 5 donuts and 3 bagels precisely? And even though we have 2 equations and one unknown, we can solve for 5x plus 3y. I just did. It's 645.
Yeah.
So you got to be a little careful about taking that one equation and 2 variables to an extreme, because we've come across 2 problems now where we had 1 equation and 2 variables and we could solve for it. This is the same type problem as there were 30 women. And the women to children were 5 to 2, and the children to men were 5 to 11. It looks like you have 2 equations and 1 unknown, so you can't solve it, but it turns out you can, because there was only one possible solution when women were less than 30 that left everybody being a whole person, you know, not half a child or half a man. So anyway, let's look at number 2.
At the bakery, the price of a donut is 15 cents less than the price of a bagel. That's not going to solve it.
Not by itself at all.
No. And so since A already solved it alone, that's it.
Yeah, exactly. We don't need to consider it, which is a good thing, because considering both of them is always the toughest thing to do, I think.
I agree.
Yeah, and once we've come up with yes for one, we don't need to do that. So, and it's pretty easy to rule out 2.
One doesn't help.
Okay.
E.
What?
E.
E, neither one?
Yeah.
Good. 139. Hmm.
Okay. Jeez.
I know, that's what I said too.
So R is between 91 and 99. All right, what does that mean? Let me see. 91. All right. That all depends on what S would be if it was terminating. But I'm sure there's something at work here.
Mm-hmm.
If you were to divide,
What's the easier one to analyze?
probably 2.
Okay, let's do that then. Because analyzing 2 may give us some insight on this problem.
Okay, if S was 4, that means any even number more than likely is going to divide pretty
It means
well.
R can be anything.
R could be anything, but if it was an even number, I'm sure it'll be a terminating integer. I don't see
Okay,
how
so
it
let's
could.
pick some numbers. Let's try some.
Let's
2/4,
pick,
that's a terminating integer. What is not a terminating?
if you get some odd number up there, like 9, and you put,
Well, 9 I think is a terminating decimal. I mean 1/9 is. I'm trying to think of what kind of denominator would automatically make a non-terminating fraction. The only things I can think of are square root of 2, square root of 3. These are all irrational, so any square root is irrational. But, gosh, as far as fractions go...
because they're at,
Well, let's look at 4. Let's try some others. What other numbers can we put as a numerator?
The second statement's making you question what type of denominator could you put in there to make it non-terminating.
Yeah, I don't think there is one.
So
Notice that I can try 3/4, that's 0.75. I can try 4/4, that's 1. Any number greater than 4 is going to be the same as the numbers 1 through 3. Right? In other words, 5/4 is the same as 1 and 1/4. So if that's terminating, then that's terminating.
I don't follow that logic, but
well, the only numbers I have to test are 1, 2, 3, and 4 for the numerator. I don't care about numbers bigger than 4 because every number bigger than 4, for instance 5/4, can reduce that fraction to 1 and 1/4. Or 7/4 reduces to 1 and 3/4. So I always am only looking at 1/4, 2/4, 3/4, or 4/4, and they're all terminating.
So 4 always terminates.
So with S is 4, that does answer, is R over S a terminating decimal? So the answer is either B or D. Now, R being between 90 and 100.
Yeah, those numbers, and you don't know what S is.
Yeah, you don't know what S is. Can be
For example, on 93, if you divided 93 by, say, a 9,
you get 10 and 1/3, which is a terminating.
well, 1/3, it'd be a repeating number.
Right. That's a terminating decimal. 0.3333 is terminating.
Why is that terminating? Doesn't it keep on going?
It does, but it's all the same. It's forever 3s. In other words, 0.82 is terminating because it goes 0.82, 82, 82, 82. Even 5.096 goes 5.096, 096, 096.
Oh,
It's a finite. Notice it has a finite number of non-zero digits. is a terminating decimal.
Finite, meaning it has to stop at some point.
Well, you can have 3, you can have 2, or you can have 1. But these are repeating, these are terminating decimals.
Are you sure?
Well, from the examples they gave, yes, I am.
I don't know about that.
No, I know what they mean. The question is, are any of these, could they be not terminating? And that's what's difficult to tell. I'm not sure how many fractions are not terminating. And in fact, well, here's something. The definition of irrational number compared to a rational number. Pi is irrational, and pi is not terminating. It's 3.1415826, goes on forever without repeating. So it has no repetition at any place. So it does not have a finite number of non-zero digits. It actually has an infinite number of non-zero digits.
Logically, I don't think you can have a set of 9 numbers and it be non-repeating infinitely.
Oh yeah, pi is 1.
There's no way.
So is square root of 2, so is any square root that doesn't come out to be a perfect square. Sure, square root of 2, square root of 3, square root of 5, they're all irrational numbers.
Okay.
Okay, look it up on your calculator. No matter how many places you take it out, you will not see any repetition.
Jeez.
Okay, so that's the definition between irrational and rational. Well, the other definition for rational is that it can be expressed as a fraction. So if I have a rational number, it is a terminating decimal. Has to be. So anything that I can express as a fraction is a terminating decimal. And obviously 91 over any number is a number that I can express as a fraction. The same with any of these numbers. It doesn't matter what the denominator is, I have a rational number. The denominator...
Because where you're getting to, it's D, right?
Yes.
All right. I just want to go on because this is such a complex theory that I get it, and I don't think it'd be worth too much more.
That's fine. No, I get that. Okay, 140.
Now, how much information can I gather from that picture?
Only what they state. They don't state that that's an equilateral triangle. They don't state that there's any isosceles triangles. Statement 2. Sometimes when you read the statements 1 and 2, it kind of tells you what you can get and what you can't get from the stem. In other words, we cannot assume that those were isosceles triangles.
No.
And we get that when we read statement 2.
Okay, so now those can't be similar triangles, can they?
No, similar triangles have to have the same 3 angles.
Same 3 angles.
These clearly do not.
Right. Okay, so they only share the base as far as I can tell, and now they're both isosceles according to statement 2.
Right.
So what is the value of x and y? Okay.
Let's look at statement 2 only for the moment.
Okay.
I realize that it doesn't look as easy as statement 1, but it actually is.
Both
Easy.
isosceles. Well, I don't know if that's telling me much by way of angles.
Well, think graphically. Try to move these things around like I was demonstrating last time we were doing an online session, They want to know what x and y are, and the only thing they're telling us is that that's the same as that, and that's the same as that. Actually, I need double slits for that because it's not the same measurement. But
well, if you decrease the angle of x,
mm-hmm.
you change the angles at A and C.
But I wouldn't affect y. I wouldn't affect the fact that there was an isosceles triangle. In other words, can't I draw this picture like this? This side still equal to this side, and this side still equal to that side, but obviously y has increased a lot, and x has stayed exactly the same.
I don't know if that picture would be true.
What do you mean? In other words, knowing that this is isosceles and this is isosceles doesn't keep me from moving the point D down halfway. I can still make an isosceles triangle from ADC by doing it the way I did in my bottom picture.
Okay.
I didn't change x. I changed y, though, but I still have two isosceles triangles.
Okay, you just moved it down.
Right. Proving to myself that I cannot answer what's the value of x plus y by merely knowing that they're both isosceles.
Oh my goodness, that's such a smart strategy.
Okay. Well, this is kind of what I mean by the graphical. Move it in your mind graphically, and you can see that if I just drop this point, I'm going to change the angle y without changing the angle x and without violating that.
So that tells you that you can't define y sufficiently, so then therefore you can't get x plus y.
Right. In other words, if I can change y and I didn't change x, and they still fit this number 2, they're both still isosceles, then I can't tell what x plus y is.
All right. So taking statement 1 now, x is 70, and then tell me anything about y, how much y could be. So that wouldn't be sufficient, really.
And in fact, in the drawing that I just did,
You proved that together they're not enough either.
right, I did. Because it doesn't matter if I put a 70 in there for x. I still change y by being able to drop point D down a notch.
Yeah.
So this would be E.
Okay.
Okay?
Next one is Committee X and Committee Y have no common members, which have no common members will combine to form Committee Z. Does Committee X have more members than Committee Y? One alone is not sufficient.
Oh. How about 2?
Well, no. No, so they have to be combined. Now this is where this gets complicated, I think. So Committee X is on this side, it's 25.7, and on the other side is 29.3.
So how do you average 25.7 and 29.3 to get 26.6?
One second. Well,
and notice the question, does Committee X have more members than Committee Y? So once again, how would I possibly end up with an average that is so much closer to X than Y?
it can either be that the numbers, the ages are lower, very low, or there's more members.
Let me ask this question. What's halfway in between there? That's 3.6, so 1.8. So if I said the average age was this, which is exactly halfway between, remember what the stem says. They have no common members and they're joining up. So maybe there's 20 members in Committee X and there's 15 in Committee Y. And they join up. And Statement 1 tells us the average age of Committee X and Committee Y, and Statement 2 tells us the average age of the committee that is formed when they all add together. So if I told you the average age was 27.5, wouldn't that tell you that there had to be an equal number of people in X and Y?
I don't think so, because
Well, what if I had 20 people in X and 10 people in Y? The average age is going to be closer to that number than this number. It's not going to be halfway in between. It's going to be on the left side of that halfway in between.
Right.
And if I had more members in Y than X, it would be reversed.
So going back to what we had found earlier, where 26.6.
The fact that the average is 26.6 tells you there has to be more members in X than Y.
Well, just since it's age, can it be that their ages are just so much more younger? They have one person that's 45, and then a ton of other people that are 5 years
have
old.
10 5-year-olds and 10 11-year-olds. The average age of the group is 8.
Yeah.
But if I have 25-year-olds, the average age of the group is going to be less than 8. It's going to be somewhere between 5 and 8.
Yeah, the principle is always going to be true.
So the fact that combined, we do know there's more members than X than Y. I think this actually would have been a better problem if they would have said, how many members are there in X or Y? We would not have been able to answer that. But we can tell that there's more members in X just because this average age was closer to the average age of Committee X.
Yep. All right. That was my initial intuition when I saw that, but I just I started asking myself proof. But if I had to guess, I would have guessed that you could tell.
It's a little like averaging 30 miles an hour with 60 miles an hour. If we spent equal times driving each, the average is going to be 45 miles an hour. But if we spend more of the time going 30 than 60, this average is going to be closer to 30 than it is 60.
Yeah.
And we've discovered that if you go to Colorado Springs and you drive half the distance at that and half the distance at that, you end up spending twice as much time going 30 miles an hour, so the average actually is closer to the 30. It's 2/3 of the way there. Notice that that's exactly 2/3 of the way towards the 30 from the 60.
Yep, yep, yep.
Because it spent 2/3 of the time going that speed. All right.
$42.
Oh, yeah, I got to cover it up slightly.
One's not sufficient.
Okay.
So statement 2 tells us that she earned at least $60,000 more.
Right.
than the
Statement 2 alone obviously doesn't answer the question. It doesn't tell you anything about her commission rate. So it's nice to be able to get to a point where you can say neither one of them alone work. Because now you've narrowed down, if you can't go any further, you've narrowed it down between C and E.
I hate that choice.
Well, I know, and I'm not saying we can't figure it out. I'm just saying that that's an important step to reach.
Right.
Is the point where you got both of them ruled out, because it really does give you a 50-50 guess, which is much better than a 1/5 chance.
So Jean's commission was 5% of the total amount of sales. Right now, her total amount of sales were at least 60,000 plus X plus X. So 60,000 plus 2X equals sum total, and you take 5% of that.
Right.
How do you solve for X?
Rather than doing it algebraically, I really think you'd be better off if you pick some numbers.
All right.
You did, in a way. You said that she made 60,000 more in the second half than the first half, and that's true.
So
She might have made 10,000 in the first 6 months. That means she made 70,000 in the next 6 months, right?
Yeah.
Well, couldn't she have made 100,000 in the first 6 months and 160,000 in the next 6 months?
Right. She could have. So it's not sufficient.
Both of them together are not sufficient. Both of them together satisfy the stem, number 1 and number 2, and yet I can't tell how much commission she made. 5% of this is not the same as 5% of that.
Yeah. Intuitively, I knew that, but
Yeah.
GMAT's so tricky now that I hesitate to just answer it.
I know exactly what you're saying. And in fact, the easier the problem is, the more I hesitate, because the more I'm suspicious that it's a trick question.
All right, 143. So I'm going to pick numbers.
Good. I was going to suggest it, but I wanted to wait and let you find that yourself.
I have if stock X increased by 10%, and say stock X was 100, so it's 110 now, which means that stock which means that Y original equaled 110, right? So if Y original equaled
No,
100,
no, we don't know from here. You're analyzing number one?
yeah.
Okay. So the increase per share price of stock X, which is 110, was equal to the price of stock Y.
So now decrease stock Y by 110%.
Well, now hold on. So what did stock Y decrease to?
Stock Y decreased to $99. So now, if I started with X at 100 and stock Y went down to 99, can I find the percent? Yes, I can.
Well, we can for that.
But that's for numbers that I picked.
Let's pick another set of numbers and see if we get this same rate.
All right, let me see if I can pick. Should I pick 10 again, or should I pick something really different?
Well, I picked 100 the first time. Oh, you mean an increase of 10%? No, it tells you 10%. I don't know.
I don't want. I'm asking if I should use 10, but
I wouldn't. I would pick a different number.
Right. Okay. So let's say X is 25.
25, okay. Only problem with that number is it introduces fractions. So I would pick a number that is not a fractional number.
But then it'd be a multiple. It'd be a factor of 100. It'd be a 30, a 40, a 50.
Okay, it's still doable. I'm not saying not doable. Okay, so what does it go up to? 2750. So they're saying Y is 2750, and it drops by 10%. So now I got to subtract 275 from that. Are you seeing the problems that happen? By introducing decimals, I've made the problem a lot harder. Not solvable, just harder.
Right.
So the question is, now, is 2475 over 25 the same fraction as this?
It's hard to make that comparison.
Multiply top and bottom by 4.
For the 2475?
Yeah, multiply top and bottom by 4, you get 99 over 100. Now, how did I know that? Well, I can tell that multiplying that number by 4 is the same as multiplying 25 by 4 and taking away 4 quarters. So I know that number is 99.
Yeah.
In other words, I didn't do that multiplication this way. I did it 4 times 25, I know is 100, and I'm 25 cents short of 25. 4 quarters is $1, so this has got to be $1 short of 100. And now, since I got the same ratio using different numbers, I'm going to assume that that's enough.
All right, statement 2.
Okay. So do these numbers work? Do these numbers fit statement 2? What was the increase in price per share of stock X? $10, right, with these numbers?
Yeah.
What was the decrease in stock Y?
11.
Hold on a second. I'm using information from the stem to do that. I mean, I'm using information from number 1.
Right.
So the increase in the price per share of stock X was 10/11. So if stock X went up to 110 and stock Y dropped by 10%, I can do that. Actually, I'm only using information from the stem.
I just don't even understand what they're trying to tell me. The increase in the price per share of stock X was 10/11ths, the decrease?
Right. In other words, the increase was 10. The decrease of stock Y was 11, so that ratio is 10/11.
How do you ever find that? Why would it be?
Well, when you pick numbers, you have to pick numbers that make that ratio equal to 10/11ths. So I picked numbers. I had stock go up 10%, and I had stock Y go down 10%, which is all in the stem. And I realized with these set of numbers, I get a ratio of 10/11ths. So again, let's pick another set of numbers, fit the criterion from point 2 and the stem, and see if we get a different ratio. This time, let's pick easy numbers. How about stock X of 50?
Okay.
And Y, this time I'm going to make it 100. So what's X go up to?
55.
What's Y go down to?
90.
And they want the ratio of X's increase, which is 5, over Y's decrease, which is 10. That's not 10/11ths. Hold on a second. I have to make it 10/11ths. How do I make it 10/11ths? By making my denominator half of 11. So my denominator has to be 5.5, which means Y has to drop by 5.5. So Y would have to be, go from that to 50 to drop, well, I'm not sure what we're doing either. I mean, I'm kind of playing around with it here. In other words, they're telling me with statement 2, they're telling me that stock X has to go up 10/11ths of whatever stock Y does. So I can't pick any numbers. I have to pick numbers where that ratio is 10/11ths. And if I can do it and still fit the stem, I'm okay. But notice that I'm not able to do that here. In other words, if I let X go from 50 to 55, it goes up by 10, it goes up by 5. So in order for that ratio to be 10/11ths, Y has to drop by 5.5. So it would have to go from 55.5 down to 50. But notice that that is not a 10% drop. Or is it? Let's see. I want to subtract from this.
It is a 55.
No, it really isn't. If I take away 10% of Y's price, I don't get 50. I get 49.50. Here's 10% right there, and I'm subtracting it from this. I don't get a 0 as the last digit. I get 49.95. So if it goes from 55.50 to 50, which is my 5.5 that I need in the denominator, it's not dropping 10%. So these numbers don't work. In other words, these two numbers fit this description, but they don't fit the stem now. These two numbers did. When I picked 100 and 110, everything fit. It fit the stem and it fit number 2. But that's because I luckily picked 100 and 110. That's the only reason it fit.
All right, this problem's not giving me any. We
All
have
right.
to move on. All right.
Okay. Need to go to the next page.
So we have 1/2 base times height equals 4. So base times height equals 8. Can be 2 times 4. Can equal 16 times 1/2. Can equal.
What is the area of square region B is 9? Tell me
So now
about this triangle.
it's telling me that length times width is more than probably just 3.
Actually, it tells me something very specific about that side.
So the
What is
height
that
is
side length?
3.
Okay. So if we know that that's 3, and we know that the area of that is 4, that means I can solve for x.
Yeah.
And if I can put a number on x, I can put a number on z, because it's a right triangle. Once I can put a number on z, I know the area of region A, because this is z. It would be z squared.
Not go any further there. Then the area of the region C is 64/9. Right. So again, they're giving me an area. That area to square, so both sides are equal to the same. I'm gonna take the square of it and get
Square root.
8. Yeah, square root is 8/3.
Hmm?
That's one of the sides. It's the same principle.
Exactly.
So D.
If we know the area of D, we can figure out Y, and if we know Y, we can figure out Z, and if we know Z, we can figure out that area. For some reason, I find the geometry data sufficiencies a lot easier than other data sufficiencies.
Sarah's age is exactly twice Bill's age. What is Sarah's age?
And I remember saying that all age problems are back solving, unless they're data sufficiency,
Right.
and then they're not.
About 4 years ago, Sarah's 8. Mine is 4. She's now 4. She was exactly, that doesn't work. Say she's 12, 16. Means that he was 4. You could put a bunch of numbers in there. One's not helping me. 8 years from now, Sarah's age will be exactly 1.5 times Bill's.
Well, first of all, let's go back to 1. I think 1 does answer it. Why? Because Sarah is equal to 2 Bill, right? From the stem. And number 1 says is that 4 years ago, which is Sarah minus 4, is equal to 3 Bill minus 4.
Just two different equations in that.
2 equations, 2 unknowns. You've got to be able to solve for Sarah.
Sure can.
Without doing it. You want to be able to recognize that if you can write 2 equations and 2 unknowns, you can solve for it.
And then part 2 is 8 years from now. Sarah plus 8 equals 1.5 bills. So it's another equation.
Sarah plus 8 will be equal to 1.5 B plus 8. Not that we need that. In other words, not that we need to be exact, because even without this 8, it still tells me I can solve it.
Right. Okay.
And there can only be one solution when you have 2 equations and 2 unknowns.
Right.
For S and B.
All right, Dave.
Okay?
Thank you, sir.
Take your test on Wednesday
Sure do.
in the morning.
Yeah.
Good luck. How long is that test? Is it like a 3.5-hour test?
4 hours.
4 hours? Are you kidding me? No breaks? Or how big a break?
You get 8-minute breaks. Two 8-minute breaks.
2 8-minute breaks an hour or something?
Yeah. Every hour and a half.
All right. I'm going to leave one last thought in your head.
What's that, Dave?
Pick numbers.
Yeah.
If you don't know how to do a problem, just pick some numbers. It might not necessarily be the way to go, but it will sometimes illuminate the problem for you.
It just gets you started, at least.
Yes, it gets you started.
I think that's the best advice I could have gotten today. So,
All right.
thanks a lot, Dave.
Well, good luck. I hope you do well on it.
I'll let you know.
Okay. Thanks,
All
Steve.
right.
Bye-bye.
Bye.